Hello everyone. This is a quick video just to confirm how to go about preparing for the first assessment, the force plate assessment as I like to call it now. I felt I was sort of covered this explicitly in lecture, but I'm concerned because I've received an email that suggests that some of you are having some concerns as how to actually go about preparing for this, and I hope to address those issues and concerns today. The first thing I would do, if you're ever having any queries about an assessment, is go to the good old module information sheet and look under assessment criteria. So the practical observation assessment here is assessed under learning outcome 3, which is here, and therefore the assessment criteria 3. So you must have met this criteria and the learning outcome in order to have passed the assessment. This is a basic pass-fail criteria, and how well you achieve this determines your grade. So the criteria states that the student must have interpreted basic biomechanical data to develop a sound rationale of how and why kinetic and kinematic variables are interrelated. Now that's a bit jargon heavy, but we can simplify this and it should be fairly straightforward once we think about what we've already done. So interpreted, so there's something you're going to need to interpret, obviously. Biomechanical lab data. Now we all know that you are going to have to analyse and describe what's going on in 3 different force traces. That would be the walking, running and counter movement jump squat trace. So that's what we're getting at there. You need to be able to interpret that data, explain what those squiggly lines mean to me, and discuss information around it basically, and relate the kinetics, because that's what the force plate is. It's a kinetic measuring device. It measures kinetics, but of course kinetics and kinematics are interrelated. Movement of forces cause movement and so on. So what movement was occurring on the force plate for those forces to occur? So I would rephrase this as, I now need to be able to interpret the force traces and explain the relationship between movement and those traces, basically, and why they occurred. And all you have to do is simplify these terms in ways that are a bit less jargon heavy, and you've got a good starting point. So let's look at some core topics that you're going to want to cover in preparation for this assessment. The first one would be linear kinetics, and I would consider this a very important question to be able to answer. What is a force? There are several key topics that come up under linear kinetics that we've covered. So force, momentum, impulse, impulse-momentum relationship, rate of force development. I'm not saying all of those will come up, but they are crucial to understanding how a force plate works. So I would consider those essential revision material. Just scroll through the lecture slides here. You don't have to do any math, but it doesn't hurt to be able to explain things using equations. The law of motions, again, I would consider this an essential topic to be able to explain, and not just tell me what the law of motion is, not just be able to say, oh, for every action there's an equal and opposite reaction. Okay, what does that mean for force plate analysis? How is that relevant, what you've just said? And actually relate it to the scenario that you're being assessed on. is the most important thing. Now, all of these laws are really just different ways of describing the same thing, using slightly different information, but they are basically describing the same thing. Once you really familiarise yourself with them, you'll begin to see. And they all relate to force plate analysis, of course they do. It's easiest to relate the third law because we are measuring ground reaction forces, but you might get asked, pick your favourite law of motion and explain to me how it relates to force plate analysis, or you might get asked, tell me how the second law of motion relates to force plate analysis. You don't know what's going to come up, you might not get asked about them at all, but I would consider these essential revision criteria. Inertia, what is inertia? How does it differ from mass even? What is an inertial force? That's pretty high there on the level of importance. Weight is crucial for force plate analysis. We weigh people on a force plate. Your kitchen scales give you your bathroom. Oh, sorry, it's quite late when I'm making this. I'm a bit weary. Your bathroom scales give you mass. Your force plate, if you have one, gives you someone's weight. What's the difference? Why do we want to know someone's weight? What's the importance of that? We've discussed this in great length. Let's move on then. So, excuse me, whilst I scroll back to the beginning. Linear kinetics continued. So impulse, remember that force is measured up the y-axis, time along the x, therefore the area underneath this line is impulse. So impulse, I would say, is as essential as force to understand what a force plate actually does. There's a subtle difference between the two, but it's a very important difference. Can you explain, for example, the difference between force, production and dissipation? Or you could easily rephrase this to say impulse production and impulse dissipation, because we're starting to factor in time into the equation. Momentum, what is momentum? How is it relevant? And most importantly, what is the impulse-momentum relationship? How do these two values relate to each other? Again, how does that relate to force plate analysis? Again, I would consider this pretty high priority if I was preparing for this assessment. Head explosion. You can see I've explained this here, so you should be okay. Rate of force development. We don't see it so often in the literature, but it might come up. You might get asked, I don't know, what's the difference between impulse and rate of force development? Maybe if, the better you do, the harder the questions are, you might get asked, why don't we see rate of force development so often, do you think? This isn't something we've covered. But if you're doing really well, as I say, you get harder questions. This is where I expect you to show some wider reading. And really more so than anything, just to answer that question, you don't actually need to know any more information. You just need to think critically about the question. Why is it we don't see rate of force development as often as an outcome measure compared to impulse? Why do most papers just report impulse and not rate of force development? I'm not saying it will come up, it might do, it might not, who knows? I know, but you don't. What rate of force development is, and so on. Then the most essential of the essentials, again, sorry, just scroll through. You might guess I recorded a previous video and I thought I was recording a video and I realised I hadn't hit record, so I'm having to scroll back through all these slides. What is an inertial force? We spent a lot of time explaining how inertial forces occur. and the fundamentals of what an inertial force is. Remember, a force plate basically measures your weight and the inertial force, as we showed here. Got the weight of the participant, weight of the bar, and the inertial force. Where does that inertial force come from? Remember, this is Newton's law of motion in action here. There is an action force acting down on the force plate, which consists of the weight of the bar, the participant, and the inertial force. We measure the ground reaction force. And this will be a positive number, this would be a negative number, but for every action there is an equal and opposite reaction, so they will be the same. So we can just infer that whatever value we get here is the same as what was being applied downwards onto the plate. You might want to tell me what a lion is. Maybe a polar bear. Who would win in a fight? I am joking here, by the way. Just in case, there's always one who takes my joke. I'm too dry / silly with my humour. So, how do we explain the three force vectors that we measure on the force plate? I mean, they're here: side to side, front and back, vertical, anterior, posterior, vertical, medial, lateral, ground reaction forces. I've even attempted, this was really hard, trying to get them all in the right place so they don't overlap. Here are the action forces. Here's the reaction. Action, reaction, action, reaction. Look at that. So we have a posterior, a vertical but downwards, and a lateral action force, meaning the force plate would measure an equal and opposite vertical but upwards, anterior and medial ground reaction force. There we are. It's all here for you. Admittedly, you haven't been in the lab for obvious reasons, but we still discussed some of the practical considerations of setting up a force plate. Sampling rate. What sampling rate is acceptable for research? What sampling rate is acceptable for just everyday demonstrations? Again, weight, why we weigh someone, how we weigh someone on the force plate. You know, the value of this, we always weigh our participants. Every participant gets their weight taken, and the relevance of that. Again, essential information here. What do these lines mean? What is this? What is this FZ here? What is this FY? What was going on here? This is the walking trace, obviously, but what does this mean? You won't be given this exact example, but you'll be given one very, very, very similar. So you need to be able to explain what the key features of the walking force trace, the two bunny ears, what their proper name is. We don't call them bunny ears, we call them something else. What is that? You could also take this opportunity to demonstrate how a anterior-posterior force is presented, how you present 3D information on a 2D screen. I'm going the wrong way, bear with me. Some more practical considerations. When your participant is in the laboratory, double stepping here, we call this is an unacceptable trial. Cross stepping, these are just terms, as I said at the time, that I use. They're not official biomechanics terminology, but they're terms that I use. This is double stepping. I think of this because 2 feet when all you need is one on the force plate, and cross stepping, you've crossed over onto the other plate. This would be cross jumping, I suppose you could call it. This dark grey or this light grey pair of foot imprints shows you where the foot was when this person was ascending into the vertical jump, and this shows you where they landed, so they landed on the wrong plate. Maybe you get asked a question on why do we measure with both feet on one plate, and what would be the benefit of measuring having one foot on one plate and one on the other? Sometimes we do that. Sometimes we have 1 foot on each, 1 foot. Sometimes we have 2 feet on one plate. Why is that? what might we get from that? Do we tell our participants where the force plate is? If so, why? If not, why? Things like that. Overstepping here, this is obviously another practical consideration. You have to watch your participant when they're performing their trials. Here's our running trace. This is a pretty good running trace. Here's what we usually expect to see. So this peak here, this impact transient, is what we would normally see. Here we kind of see it developing here, but this person obviously had very good running form. The running trace is best explained, I think, by comparing it to the walking trace. Just explaining the magnitude of force, the duration of time that the foot was in contact with the ground for, and why this is. So if I say, what's the difference between walking and running trace, you can answer that competently. Right. The vertical jump trace here, this isn't probably the best one I could have chosen, but this was just hesitancy here. Usually you have almost the two active peaks again, but if you recall during the lecture I explained during the ascent phase what kinematic motion was occurring at each stage that is depicted here. So that would help explain the ascent phase. What about the descent phase? What's going on here? Why doesn't the force plate start recording at 0? Why is there this force here? What is this force? Things like that. And these applied examples here, which we only briefly mentioned, were really, more so than anything, to just give you some examples of things to go away and revise in your own time. Topics that you could just enter into summon. Sprinting and ground reaction forces. Squatting, ground reaction forces. Shin splints, ground reaction forces. You'll find a paper, just read the abstract, and then you've demonstrated some wider reading. Simple as that. It's you know, you haven't got to do all of them. Come up with your own. Pick whatever your favourite sport or type of exercise is. I guarantee at some point someone will have analysed it with a force plate. So read up on it. What else have we got? Okay, so I would pick a good textbook or research article that I've shared with you on Brightspace. So this is my copy of Biomechanics of Sport and Exercise by McGuinness. It's an e-copy, obviously. And their section on force, they call them force platforms here, I don't know why. It's quite short. There's not a huge amount of information here. There is a bit more earlier on in the previous chapter here when they're talking about injuries. Here, there's a little segment here. But most good textbooks will have some sort of information in there about force plates. So it's basically a case of I'll find another slide to just rest on whilst we're waiting to move on. There we go. Find a good textbook and then use the many resources that are provided for you on Brightspace under the force plate analysis section. There is a huge amount of literature on there. Not all of it you need to know. I don't need to know, as I say, how a force plate works in terms of the actual mechanics of how it is able to transduce the pressure that's applied to it into a squiggling line on my PC screen, but the basics you will need to know. Force plate analysis is, like anything, any topic is complicated if you study it in enough detail. So you don't need to go into much detail as to how the plate actually works, if any. But so you can skim over a large portion of some of the information that I've put on Brightspace, but there is some really good information on there, so do take advantage of it. So finally then, let's just cover how I would prepare for this assessment. So I've just drawn up a basic crib sheet here. you all know what the first question, or it's not really even a question, is more of a statement, isn't it? Tell me what you know about force plate analysis. What it is, what it does, how it works, anything. This is deliberately open. So I would write down 5 to 10 questions that you think may come up. So for example, I've written the first question, which I know will come up. I've written what is a force. I've written what is impulse. I've written what is the impulse-momentum relationship. And then you could have another 3 on the walking, running, jumping traces. Trace, because you know they'll come up. So actually you know 4 questions that are going to come up really, because the first one will come up again, well, statement really, and you know for a fact you're going to get asked about the walking trace, the running trace and the jumping trace, so they're a given. These others I can't guarantee, but there's certainly topics that I would revise if I was preparing for this assessment. So what I would do then, once I've written out my questions, is I would use them to guide my revision. So get your resources together, find a few research articles, use the lecture recordings that we've got on Brightspace of the lectures that we've had, and make as many notes as possible, and then basically populate the area under these questions with some information. And I've only written some basic information under here. I'm not giving away too much. I've just written under what is a force, I've bullet pointed push and pull, interaction between 2 objects, and movement and or deformation, in that it causes movement and or deformation. And the reason I would say present the information on your crib sheet as a bullet point, in a bullet point fashion, as opposed to sentences and script, more of a script, is because if you learn a script, and let's say you learn a little paragraph of text about what is impulse, and I don't ask you what impulse is, but I do ask you what the impulse-momentum relationship is, you'll only be able to answer half that question, because the other half will just be the momentum portion you won't be prepared for. So it's easier to adapt the information that you've got if you've just got it in bullet point form, as opposed to a rigid script which you think, right, I hope the questions come up in this order, in this fashion, but what if they don't? So I can't do, I've given you a lot of information on what will and won't come up, so you've got an awful lot to work with here, but if you prepare it in bullet point form like this, then you can get someone to quiz you, promise them to buy you a beer, you promise them to buy you a beer or something once this whole COVID shenanigans are all over, and just practice answering those questions, and they can just tick off, yep, you got that one right, you got that one right, you got that one right, yep, good. And then once you feel confident with that, write out another 5 to 10 questions, do some reading, populate your questions with some information, some answers, and again get them to quiz you on all 10 to 20 questions that you now have, and go from there. You don't have to do it that way, but that's how I would do it. So I don't want to make this video too long, because we're at 25 minutes already, but hopefully that I've been really clear there, and I've made it as explicit as possible as to how you should go about preparing for this assessment, and importantly what topics to revise. If not, please let me know.